right, so transcendental functions are functions that transcend algebra. They go beyond adding, subtracting, multiplying, and dividing. And I would even say it goes beyond things like raising something to the second power, or the third power, or fourth power, because raising something to the second, third, fourth is really still multiplication, right? It's just repeated multiplication. So the examples of the things that we're going to see are your trig functions, exponential functions, log functions are the ones that we're going to be focused on today. And we won't look at all of the trig functions today, primarily just sine and cosine for today. We will look at the rest of the trig functions in 210 is the section where those come up. The keys you have to have memorized. I'd put me a box or something around this because you've got to know these. The derivative of sine is cosine. And the derivative of cosine is negative sine. Okay. These only apply to just like sine or cosine. So if sine is squared or something like that, it's a more complicated problem. You can't do it. But if we have something like example 1 where we just have a coefficient, right? So we just have a 2 out front. Then the coefficients, we learned in those properties yesterday, we could just like leave the coefficient where it is at and take the derivative of the other stuff and then multiply it back together. So coefficients are fine. Now if I had something like cosine of 2x, if the 2 was on the inside of the cosine, different problem, more difficult. We'll get to it, but not yet. So you won't see that yet. So part of this is just recognizing this is a simple problem and having these memorized. You for sure have to have these memorized. You will do poorly if you don't have them memorized. So on everything, like, you know, from here on out, because everything we do, we learn how to do it, and then I show you how to do it with some trig functions, right? Like it shows up. There'll be trig function derivative stuff on about every test that you take. So you've got to have them memorized. So if we're trying to take the derivative of f of x equals 2 cosine x, 2 is just a coefficient. It just stays there. And what is the derivative of cosine x? Negative sine x. Now, I usually would not write this step, but that's what's happening. You've got 2 times negative sine x, which is just going to give you negative 2 sine x. Now, y equals here looks a little bit different because I've got sine x divided by 2. But can that be written as a coefficient? 1/2 times sine x, right? So even though it's just divided by 2, it can be written like it's just a coefficient. So if you're taking the derivative here, you are going to just have 1/2 times the derivative of sine x. Some notation here. I told you the other day you can call this y prime. Let me throw one more out there at you. Sometimes you will see this called dy over dx. We'll get into why that notation is like that, but both of those mean the derivative of y. There, so it would be 1/2. The derivative of sine is cosine x, so 1/2 cosine x. And then sometimes you have some that are combinations of things we've already learned and trig. So like for number 3, your g prime of x, the derivative of 2x is just 2. And then the derivative of sine is cosine. So I would get 2 minus cosine of x. Right. So we can take the things of take the derivative of terms separated by plus or minus signs separately. We'll see if this ends up being 2x times sine x, different story. We can't do that. We've got to have a special rule. But here, we can just take our derivative. Okay, all okay here? All right, so sine and cosine are going to be very straightforward at this point. Like, derivative of sine is cosine, derivative of cosine is negative sine. You just take it and replace it and then simplify a little if you need to. All right. Let's look next at derivatives of exponentials. So if you have a to the x power, okay, the derivative of a to the x power, here a would be a number, some sort of constant. Doesn't matter what number it is, but it's a number raised to an x power. Then the derivative is itself times the natural log of whatever your base is. So like, for example, if I have example 4, let me use that dy dx notation just so you've seen it a little bit too for when it shows up other times, right? The derivative of 3 to the x is 3 to the x, but I must multiply it by natural log of the base, which is 3. That's it. It's mostly just having the rule memorized. Okay. Now, if I look at 5, it's a little trickier because I do have this 5 out front, but that 5 is just a constant, or a coefficient. It's like a scalar multiple, right? So whenever I take the derivative of this, I can just let the 5 sort of hang out front and then take the derivative of the 1.2 to the x power. So that would be 1.2 to the x power. It is itself. And then you must multiply by the natural log of 1.2. You will probably see this written, well, where they'll put that 5 and that natural log of 1.2 together somehow. Like it might be 1.2 to the x times 5 natural log of 1.2. I think they'll probably do something like that. Or they might write it out front. Yeah, if it's for your response, you could leave it as the first one for sure. Okay, 6 is a little bit of an interesting case. If I take this derivative, you could call it dy dx, you could call it y prime. Either one of those are perfectly acceptable for when you're taking a derivative of a y. The 5 is a coefficient, it just stays out front. The derivative of e to the x is e to the x. And then I've got to multiply it by the derivative, not by the natural log of the base. So natural log of e. But what is natural log of e? It is 1, because natural log is really log with the base of e. So we're doing log base e of e. So log base e of e is just 1, because those cancel out and you're just left with the exponent, which would be a 1 there. So this is really just 1, so I could just say y prime is 5e to the x. Here is the good news. Most of the time, they give us exponentials that have a base of e. Okay, so I started with this rule because this rule applies even when our base is e. But if your base is e, here, if you're taking just the derivative of y equals e to the x power, the derivative of e to the x is e to the x. And this is the one they give us most of the time. So most of the problems that you're going to run into are going to be with a base of e. They do not put a lot on there that have a base other than e. Sometimes they show up, so that's why we need to know that rule. So if I see something like example 7, it should be the easiest problem that you do if you have it memorized, if you memorize it, right? Because if I take this derivative, y prime is going to be the derivative of e to the x is e to the x. So this does not change at all. 3e to the x, that's it. 3 is the coefficient, it just hangs out there. What's the derivative of 4x? 4. So 3e to the x minus 4. 8 is just slightly more difficult. because I have a fraction right now. I've got a negative exponent. What could I do with this? Move it up to the top. So this is 6e to the positive x. And so if I find f prime of x, it is just 6e to the x. It doesn't change. Students do not have problems doing these problems. They have problems remembering what to do. That's what they do. Mm-hmm.
What's the difference between like 6 and 8?
There is none. I gave you this one to lead into the next rule. Okay. Right. So there is none. So I wanted to show you there that the rule for all bases still works for e's. It's just that natural log of e is always going to be 1, so you don't really have to put that there on the end. So we could have just said this is 5e to the x right here for that. But I was wanting to kind of like lead into why for that. So these really aren't different rules. Our a to the x, natural log of a, and our e to the x, the first rule still applies. It's just we can simplify it in that particular situation. And we see this most often, so we want to do that. And we're going to see something similar in our next step. So your derivative of log with a base of b of x is 1 over x times natural log of b. So that would look like this on number 9. F prime of x would be 1 over x times the natural log of the base, which is 5. Okay, if I did this for 10, derivative of y, you can call it y prime. Let's do a dy dx just to mix it up so you've seen both of these notations here. They're interchangeable. Some have advantages to being used at different times. We'll see later. 6 is a coefficient. I'm just going to leave it out front for right now. And I'm going to take the derivative of log base 4 of x, so that's going to be 1 over x times the natural log of 4. And in this case, what they would usually do is like that 6, you can put it over 1. They would usually put that back together, so you get 6 over x natural log of 4. Now, if you want me to show you something super crazy that evil geniuses that work at AP do sometimes to guarantee that kids that know what they're doing are not going to get the right answer. You can 6 over x natural log of 4. On a free response question, do not try to simplify that. In fact, you don't even have to multiply these two together. You can leave it, right? But if this shows up on a multiple choice question, sometimes that's not the answer choice that they leave. Sometimes they do this. 4 could be written as 2 squared, right? What can you do with exponents when you have logs? It can be pulled out front, which would give you 6 over, I'm going to write it this way, 2x natural log of 2. And then what can happen with that 6 and that 2 that's out front? They can cancel. They'll get 3 over x natural log of 2. I feel like that's a cruel thing to do on a multiple choice question, especially one that would be this easy. Because if you forgot those log rules, you're not going to get it. But I've seen it done on release questions before, so just thought I'd throw that in there as a bonus. Yes?
So technically, if you simplify it like incorrectly, you're still the right answer, right?
Yes, it would be incorrect to reduce the 6 and the 4, but it would work here, and it won't always work. It just happens to work on this problem. So it would be done this way, but that won't always work. There. All right, so 11 is a little bit like number 6 was. So I have this feeling that it's going to be easier whenever we have a natural log. So if I'm using the rules for this function right here, if I take the derivative of g right here, I will get 1 over x times the natural log of the base. What's the base on that one? E. And what did we just say natural log of e is? It's just 1. So this really ends up just being 1 over x. And that happens every time that you have a natural log. So, rather than having to use this rule, if we have the derivative of natural log of x, it is just going to be 1 over x. All right, we could multiply it by natural log of e on the bottom, but it's just 1, so this is more simple. Much like the exponentials, most of the problems they give us that are logs are going to be natural logs. So we're going to see this a lot more often than we see logs with different bases. So when I see something like this, I could just say y prime equals 6 is a coefficient, so it just kind of hangs out front. The derivative of natural log of x is just 1 over x. They will probably put that 6 over 1 and multiply this back together and just write it as 6 over x. You might see some of these in like a combination sort of problem where you've got parts of it are natural logs and parts of it are just regular derivatives. So if you see this, you would have 3 times 1 over x plus our derivative of 5x would just be 5. And so that would be 3 over x plus 5. Now something I feel a little less evil than the natural log thing that they might do here is they might get common denominators for that. For response, definitely it's fine to leave it 3 over x plus 5. But here, they might multiply the top and bottom by x here. So you might also see 3 plus 5x over x. They might do something like that if it's a multiple choice question. So whenever you're doing these problems, if you'll check them in the back of the book, see what their answer looks like and try to get your answer to match it. So you may have stopped right here at 3 over x plus 5. See what the back of the book looks like to see if that's how they left it. It doesn't mean that's the right way to leave it. I just want you to be able to manipulate what you have to get what they've got, because that's good practice for multiple choice. Okay, questions? All right, so they might ask you to do some of this with things like writing the equation of a tangent line. So anytime we see equation of the line tangent, we need a point, we need a slope, and we need an equation. So for the point, you're going to have to find just f of 1, right? You're just plugging into the original equation. So in this case, f of 1 would be 4 times 1 minus the natural log of 1. So 4 times 1 is 4. Anybody remember natural log of 1? 0. So you just get 4 for this. So our point is 1, 4. Our slope here, we need f prime of 1. To find f prime of 1, you need to first find f prime of x. So find f prime of x first. Label it as f prime of x. These show up on free response all the time, and you need to label everything clearly so you get all the points. So, because you almost for sure will get a point for the derivative of f right here. So the derivative of 4x is 4, and the derivative of natural log of x is 1 over x. So that is our derivative. Our f prime of 1 would be 4 minus 1 over 1. That's just going to give us 3. So there's our slope right there. And so our equation, we're just going to do y equals 3 times x minus 1 plus 4. There's our answer. So same process as tangent line like we were looking at on the FRQ this week. Just involves a natural log. Okay, I got us one more that we're going to do. The line y equals mx plus b is tangent to the graph of g of x equals 3e to the x plus 2 at x equals 2. What are the values of m and b? So this is another one that is going to make you like do y equals mx plus b form, but we're still just doing the same thing we did on the last problem, right? So we need a point for the tangent line. So we're going to have g of 2 because our x coordinate here is 2. So we got 3e squared plus 2. Now, you may notice that I did not put anything about this being calculator active here. Can we figure this out without it being calculator active? We can't get a decimal for that. Like, I don't know it. But this is not supposed to be a calculator active problem. So, your point, we plugged into our y coordinate is 3e squared plus 2. If this was calculator active, I could type it into the calculator and get a decimal for that. But I can't because it's not calculator active. But I can still do it. It's just my answer is going to be ugly, and I don't like it. But they do this to us, so we've got to do it anyway. So if we want to know our slope, what do we do for slope? What? G prime of 2. But to find g prime of 2, we would first have to find g prime of x. What is the derivative of 3e to the x? The easiest one we do, right? It is 3e to the x. It's itself. Okay? What about the derivative of 2? It's 0. So your derivative, your g prime of x, is just 3e to the x. And so g prime of 2 is going to be 3e squared. This is your slope. So then we can write our equation. It's so ugly. I don't like it, but it is what it is. We got y equals, the slope is 3e squared times x minus 2 plus the y coordinate, which is 3e squared plus 2. Yes, so we are going to have to distribute here because the question is asking us for m and b, meaning we need like slope and y-intercept of that line. So we've got to distribute. Our answer is not pretty on this one, right? We've got to distribute. And so when I do that, I get 3e squared times x minus 6e squared plus 3e squared plus 2. And I could combine that negative 6e squared and the positive 3e squared. So that would look like this. Y equals 3e squared times x minus 6e squared plus 2. Anything else I can put together there? I'm sorry. It should be a 3. That's a 3 right there. I'm going to rewrite that. It's ugly. And the eraser does not work on this, which is fine. But, okay. Alright, so the question's asking us for M and for B. What is M? What is it, Zach? Almost. Don't include the X, right? Because the X is the variable part that is not. Our slope needs to just be a number. So our M is going to be whatever is multiplied by your X. So the 3e squared. And that is a number, even though it doesn't really look like it. If you type 3e squared into the calculator, it'll give you a decimal. All right. So our M is 3e squared. What's B? It is everything else over here. It's minus 3e squared plus 2. It's all this stuff on the end. Because if I type this stuff into a calculator, it will give me a decimal for it, right? So these are your answers here. They're not necessarily like difficult. It's just usually kids fall apart because your answer looks so ugly, right? So the assignment for this is going to be 19 through 24, 35 through 38, 49 through 52 on page 143. It is all of those problems, not odds this time there. So you're going to do all of those. It is not due until Monday because tomorrow we won't have time to go over anything for that. But you got about 15 minutes now, so you should be able to get a good chunk of it done before you go because a lot of these are very quick.